Hello, everyone. My name is Agnieszka Chowaniec-Michalak, but your version is very nice.
I'm sorry.
I like it, really. Um, I'm a PhD student at the Wrocław University of Science and Technology in Poland at the Faculty of Civil Engineering. It is pleasure to be here in beautiful Catania, and I'm very happy to take part in this conference. Uh, in the introduction, I will briefly discuss the basic information about epoxy resin floors and research motivations. I will present the materials and methods, results, and conclusions. Beginning with the introduction, it is worth to mention that epoxy resins are widely used in construction industry as floor coatings. We can find them, for example, in industrial halls or underground parkings. As you can see in figure 2, we applied epoxy resin coatings usually on concrete substrate. They consist of 3 layers, the primer and the 2 layers of epoxy resin coating. Epoxy resins coatings have very good chemical and mechanical resistance and high adhesion. The surface is really easy to clean, which make them suitable for hygienic environments like laboratories. However, epoxy resins are very harmful to the environment. There are, for example, toxic to aquatic life, contains bisphenol A, can be irritating or allergenic, and they are relatively expensive. Because these advantages, we want to find the solution to reduce the content of epoxy resin needed to make the coating. And we want to make these materials a little more sustainable. So the idea of the research is use of waste materials as a partial replacement of epoxy resin in coating. As you can see in figure 3, mineral waste are a large proportion of all waste in Europe. Many of them are in the form of powders and stored on heaps, which cause the dusting of surrounding areas. Therefore, I decided to use waste mineral powders as fillers in epoxy resin coatings. So the aims of the study are reduce the amount of epoxy resin in floors coating and thus lower the content of harmful components, lower the cost of epoxy floor coating, find an application for waste mineral powders, verify whether the addition of waste mineral powders does not worsen the impact resistance of floor coating, and support the circular economy by reusing waste materials. Going to materials and methods. In this study, I use commercial 2-component-based epoxy resin. Component A was resin and component B was a hardener. They were mixed in weight ratio of 100 to 50. I used 2 kinds of waste granite powders. Both powders had the same chemical composition, but different particle size distribution. On the figure, you can see the particle size distribution of powder G1 with finer fraction and the G2, the larger one. I made seven mixtures, 1 reference without the powders, and 6 with powders G1 and G2. The weight ratio was 100 to 50 to 12, 100 to 50 to 36, and 100 to 50 to 60. 100 is resin, 50 is hardener, and third number is the granite powder. I applied the coating on metal plates. The average thickness of coating was 2.4 millimeters. Here you can see all prepared specimens placed side by side. The testing method is really easy. On figure you can see the weight, the place where the specimens were fixed in the general view of the test stand. There is no standard directly for floor coatings of impact resistance. Therefore, I decided to use the standard for paints and varnishes. The other researchers used also this standard for floor coatings. I used the weight 1 and 2 kilograms and dropped from height, increased in step of 25 millimeters. I recorded the minimum drop height, which caused the cracking of the coating. Moving to the results, I observed two kinds of damage. With the 1 kilogram weight, coating with waste granite powder showed only the type 1 damage. Even at the maximum drop height of 1 meter. Type 2, so the larger one, did not occur under these conditions. Type 2 damage was observed only when using 2 kilograms weight. The reference samples did not show this type of damage at all. It directly cracking into type 2 damage. Here you can see the results for type 1 damage with 1 kilogram weight. The reference, as I said, the reference samples did not show this type damage. With the height of 40 centimeters, it's the crack directly to type 2 damage. All coating with waste granite powders show higher impact resistance compared to the reference samples. The highest impact resistance was for G160. It's been for 80 centimeters. The better results were for the finer powder G1. Here you can see the results for type 2 damage with 2 kilograms weight. The reference samples showed a very low impact resistance, only 20 centimeters. All coatings with the powders significantly increased the impact resistance. The best results was observed for G236 and G260. Is the powder with the larger fraction. It is worth nothing that the is difference between shape of the cracking for reference sample and with granite powders. For granite powders, the damage was more regular and rounded, and for reference samples was more irregular. Finishing with the conclusions, granite powders improve the impact resistance of epoxy coatings compared to the reference samples. Fine waste granite powders was more effective against small point-like damage. The larger powder was more effective against larger cracking. The use of waste granite powders as a filler reduced the amount of epoxy resin needed to make the floor coating. This lowered the content of harmful components and decreased the cost of the coating. It supports the circular economy by turning waste into a valuable resource. I want adding that this study is one part of many tests which I made for epoxy resin coatings with many various waste mineral powders. And I choose this particular test because I think it's important, for example, in industrial house where it's many heavy tools and we want to avoid the damage during the everyday use, for example, for falling tools. Thank you very much for your kind attention.